All right, this is our topology. You can see that we have two different networks. We're starting with the network ID of 192.10.10.0 and a subnet mask of 255.255.255.0. This lets us know that the last octet is being used for hosts on this network that we're starting with. So we have 8 bits available to work with. The network on the left has 60 computers, and the network on the right has 25 computers. So we need to subdivide this network so that it meets the requirement for each one of the computers. Let's write down the network address and the Subnet mask. And the two requirements. We need 60 computers on network A. Network B needs 25 computers. Always start with the network that has the highest requirement. Here is my binary code for each one of the octets. These X's are going to represent the 8 available bits that we have to work with. Remember, those are part of the host right now. With 8 bits, we can create 256 different combinations. There's 256 total IP addresses this network has. One is going to be for the network ID, and the last one is going to be for the broadcast ID. That leaves us with 254 usable IP addresses for devices on this network. But we need to divide it to meet these requirements. All right, so this circle is going to represent our entire network that we're starting with. So our question is, how many bits need to stay on the right side? How many bits do we need to keep for host IP addresses? All right, so let me write down again my X's down here. And let's figure out how many combinations we could create with each one of the bits. So if I have this bit, only this bit as on the host side, how many combinations can I create? Well, I can create 0 and 1. That's 2 combinations. If I had 2 bits on the host side only and the rest all borrowed for the network, how many combinations could I create for IP addresses on each network? That's going to give me 4 different IP addresses: 0, 0, 0, 1, 1, 0, 1, 1, right? If I had only 2 bits on the right side and everything else network. Since we're trying to figure out how many bits we need to create IP addresses with for devices on the network, then we're starting from the right. Meaning that for each one of the combinations we create, everything that's part of the network is going to have 0. 1, 2, 3, 4, 5, 6. And if we converted this to decimal, we would get the number 0, 1, 2, 3. And that's all we can do with 2 different bits. If we had 3 bits, then how many combinations can we create? Well, that would allow us, this is right here. We could get started here, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Again, everything that's part of the network, we will put a 0 on. This number would equal to 4. This one would be equal to 5, 6, and 7. We would be able to create 8 different combinations with 3 bits on the right side for IP addresses on the network. Okay, so you can see there's a pattern here. If we have 1 bit, that's 2. If we have 2 bits, it doubles to 4 combinations. And each combination is going to be a different IP address number. For example, this combination right here, this on the last octet, will give us this IP address, 192.10.10.3. That's one IP address. This one right here would be the following, 192.10.10.4, and so on. Okay, so again, we start with 2 bits and we double every time. How many of those bits do we need to create a minimum of 60 combinations for 60 different computers? Well, we have 4 bits, that's going to give us 16 combinations. 5 bits is going to give us 32, still not enough. And then 6 bits is going to give us 64. That should meet the requirement. So we need a minimum of 6 bits on the right side for host IP addresses. And then we can use the other 2 bits to divide the network. How many networks can we create with 2 bits? Well, if we start from the left, 1 bit gives us 2 combinations, 2 bits gives us 4 combinations, meaning that this network right here we started with will be divided into 4 different networks. Each network, if we divide 256 and divided by 4, then each network is going to have 64 IP addresses each. 64 here, 64 here, 64 here. Right? And so we're going to use this first network for network A. And we're going to use this second one for network B. Now, network A now has 64 IP addresses, meaning that it's going to have network 192.10.10.0, 192.10.10.1, and so on, .2, .3, .4, .5, all the way up to 63. Right? If you count that 0 total IP addresses, even though it's ending at 63, you have a total of 64 IP addresses within that first network, meaning that our next network will start at the next IP address right after that. That would be 192.10.10.64. Right? Hopefully that makes sense. So our first network starts at 0 and our next network starts at .64. The network after that would start at 128. You have to count the numbers of IP addresses that are within each network, right? So you can also use that number as the increment. You'll see the pattern. If I count 64 starting from the number 64, I end up in 128. That's going to be the number for our next network. Hopefully you can see that pattern. It starts at 0, you add 64 to that, which is this number right here, the number of IP addresses on each network. That's going to give you the next network IP address. And then if you add 64 to that, you get the next network IP address. And if you add 64 to that number, you're going to get the next network IP address, which should be 192. And at the moment, each one of these IP addresses is going to have a new subnet mask. This will let the computer know that the network has been divided. It'll also let the computer know which network it belongs to. So what subnet mask are we going to have here? You need to count how many bits you have borrowed to make them part of the network. Then you're going to use this table, 128, 64, 32, 16, 8, 4, 2, 1. Then you're going to place a 1 on the values of the bits that you borrowed for the network. So 1 and 1 here, 2 bits farthest to the left. Then everything else, everything that's part of the host is going to turn to a 0. This is going to give us a subnet mask of 192 for each one of the networks. Subnet mask of .192. Now you'll notice I didn't fill out the network B, the subnet mask for network B. The reason is because at the moment it has 64 total IP addresses, but I only need 25. So I'll be wasting more than 30 IP addresses in that network that I could use in a different network. So for that reason, I'm going to divide this network one more time. And to do that, we got to look at how many bits we have left to work with. If you look here, we have 1, 2, 3, 4, 5, 6 bits to work with. How many of these bits do we need to keep on the right side to be able to create combinations for IP addresses inside the network? Well, if I have 1 bit, that gives us 2 IP addresses. 2 gives me 4, then 8, 16, 32. 32 should be more than enough for 25 computers. We'll still have 5 IP addresses left over, plus 1 for the network and 1 for the broadcast. But that's better than having more than 30 IP addresses left over that we cannot use in any other network. So that's going to allow us to borrow 1 bit to divide this network here into 2, right? Well, 1 bit gives us 2 different combinations, right? Each network is going to have 32 total IP addresses for IP addresses within that network. So a total of 32. 1 is going to be the network ID. 1 is going to be the broadcast ID, giving us with 30 IP addresses for 25 computers in that network. If we wanted to add 5 more computers, we could. I'm going to erase this real quick. We're not going to need this. Those are the network IDs for these 2 networks right here. which we're not going to be using. All right, so here's where our second network's starting, but this network only has 32 IP addresses total. So that's going to be our new increment. This will tell us where our next network starts and where this network ends. 64 plus 32, that should give us the number 96. That means that this network B is gonna start at 64. Network C starts at dot 96. The broadcast for network B is gonna be 95. And everything in between from 65 to 94 can be used for IP addresses within that network. So 65 is our first available IP address. We can give that to the router. We can give it 66 to the switch, and then 67, 68, 69 for computers inside the network, all the way up to 94. What is our new subnet mask now? Now we have to take into account every bit that we borrowed from the fourth octet. Remember that we started with 8 bits, and then we borrowed 2 bits here and 1 more bit over here. So that's 3 bits that we borrowed total. If we place that on our chart for the subnet mask, one under each one of the values for the bits that we borrowed, we get the number 224. That's going to be our new subnet mask for each one of these networks that we created. All right, so now we should have all the information we need for our 2 networks. I can get rid of that third network because we're not going to be using it at the moment, but it'll be there in case we want to increase our network later on. In case we wanted to add another room with 32 IP addresses or another room with 64 IP addresses. So now, again, here's our starting IP addresses for each one of our networks, network A and network B. And network B has 32 total IP addresses. Network A has 64. Let's move back to Packet Tracer and add all this information to our topology. Okay. So I'm gonna write down our new network addresses. Network A will have IP address 192.1.10.10.0 with a new subnet mask of 192. Network B is going to have an IP address of 192.10.10.64 with a new subnet mask of 255.255.224. Now that we have the starting IP addresses, we can start giving information or IP addresses to each one of the devices on the network. So for network A, let's start with the router. Let's give the router on the interface G01, which is part of network A, we're going to give it the first available IP address. That should be 192.1.10.10.1. And the subnet mask is going to be the same for every device inside the network. For the switch in VLAN 1, we can give it 192.10.10.2. For computer A, I can give it the IP address 192.10.10.3. Computer B can have 192.10.10.4. Then we can move to the next network. Network B starts at 192.10.10.64. So for on interface G02, which is the interface that connects to network B, we can give this interface the IP address 192.10.10.65, the next available IP address. Subnet mask is going to be the same for every device on this network. VLAN 1 can have the next available IP address. PCC can have .67, and PCD can have .68. All right, so now that we have all the information that we need on our topology, now we can start adding these IP addresses to each one of the devices. So on the first computer, go to Desktop tab, IP configuration, IP address 192.10.10.3 with a subnet mask of 255.255.255.192. And our default gateway, that's going to be the IP address for the router on the interface that we're connected to it. This is where the computer is going to send information if it's leaving the network. It's going to send it to G01. So the default gateway is going to be IP address 192.10.10.1. That's the first available IP address we gave to the interface G01 for network A. And we're done here. We're on to computer B. This one has IP address of .4, 192.10.10.4. The subnet mask by default is going to give us the default subnet mask, but that changed because we divided the network. Now it's going to be 192. Default gateway is going to be 192.10.10.1. Again, the default gateway is going to be the same for all the devices in here. The IP address we gave to G01 on router 1. Now I'm going to set up this switch so that we can remote into it. First thing I need for that is a host name. Host name S1. Then I'm going to create a password for privilege mode. Enable secret. And make this class. Then a password for the virtual interfaces. Think of those like virtual console lines. So line BTY 0 through 15. Give this a password Cisco. Then activate the password with the keyword login. Now I can go to interface VLAN 1 and give this an IP address 192.10.10.2 according to the topology. That's the IP address we're going to use. Subnet mask of 192. Remember, you have to type in no shutdown to activate this interface. From the global configuration mode, IP default dash gateway 192.10.10.1. Then I'm done with the switch. I can move on to the next switch. This switch again is in the second network, so the IP address is going to be different. Again, host name S2, enable secret, class, line BTY 0 through 15, password Cisco, login to activate the password, exit, then interface VLAN 1, IP address, the subnet mask for this network is 224. And then we need to be in global configuration mode to set up the default gateway. Once in global configuration, you're going to type in IP default gateway, and then the IP address for the default gateway. For network 2, that's going to be 192.10.10.65. Remember that. So over here on the topology, hit enter, and now I'm done here. This default gateway is needed if I want to configure the switch 1 from PCD. Right, so I've configured all the switches and the computers. Now let's move on to the router. On the router, I'm using interfaces G01 and G02. So enable config T. First thing I want to change here is the host name. I'm also going to set it out for telnet, so I can configure it without using the console cable. Enable secret class line BTY 0 through 15, password Cisco, login to activate the password, exit. Then I'm gonna go into the interfaces that require an IP address. So interface gigabit Ethernet 01 IP address 192.10.10.1. Need the Subnet Mask 255.255.255.192. Then no shutdown to activate the interface, and you'll notice it starts turning green on one side and starts communicating with the switch to make sure it has a connection. Okay, from here I can move to interface G02 and IP address 192.10.10.65 with a Subnet Mask of 255.255.224. No shutdown to activate this interface. And I want to make sure I did no shutdown on the VLAN 1, which I didn't. So configure terminal, interface VLAN 1, no shutdown. You'll see that it says change state to up. Now I've configured every device on my network. I should be able to ping from PCA to PCD. So I open PCA, go to the command prompt, type in ping, and then the IP address to computer D, which should be 68. Now that failed, so that means that I missed something. So let me check computer C and D. And I'm missing the IP addresses on those computers, so let me add those IP addresses. 192.10.10.67, Subnet Mask of 224. Default gateway is gonna be 192.10.10.65. Go to computer D. I'm also missing the IP address there. 192.10.10.68. Subnet Mask of 224. Default gateway is gonna be .65. Now, if I go back to computer A and type in the ping command one more time, I should get a reply from computer D. Now you'll notice that the first ping timed out, but the following ones I did get a reply for. The reason for this is because computer A didn't have the MAC address for computer D yet. If I do it again, I'll get 4 different replies. Because now the MAC address from the router is going to be there. Meaning that if it needs to send a message to computer D, it's going to first send it to the router, and the router will deal with it. All right. Hopefully this helps you with subnetting and with the commands on how to add the IP addresses to each one of the devices. See you in the next video.